Welcome to qnawire.
Okay, so first we can determine the final speed. So, well, the final speed is equal to the angular frequency times the amplitude, okay? And we know the angular frequency is equal to 2 pi times frequency. Therefore, we have V final is equal to 2 pi f times amplitude, which is equal to 2 pi times, so the frequency was given as 2.0 hertz. So times 2.0 hertz, and then times the amplitude, which is 0.20 meter. And this will give us the final speed is about 2.51 meter per second. So now we know, according to the law of the conservation of momentum, so the initial momentum pi must equal to the final momentum pf, since there's no heat loss in this question, since when the arrow was reached to the cars, it will sit on the horizontal and frictionless surface. So that means there's no friction, so there's no heat loss during the process. So we know the initial momentum is equal to the mass of arrow times the initial speed, which is equal to the final momentum, which is mass of arrow plus the mass of cards, let's say capital M here, and then times the final speed we just calculated. So therefore, we know the initial speed should be equal to m plus capital M times V final divided by the mass of arrow. And this will give us, we know the mass of arrow plus the mass of card is simply equal to 0.050 kilogram, and then plus 0.50 kilogram times 2.51 meter per second over 0.050 kilogram. And this will give us the initial speed was about 27.6 meter per second. So this is how fast that arrow was, okay? So this is the answer for this question.